Swayam Prabha. Digital India. Educated India.
Welcome to this 14th session of Ergonomics for Beginners Industrial Design Perspective. Now, today the last class of module number 3, that is human physical dimension concerns, that is the today's session of in this module will be class 14, that is statistical treatment of data and percentile calculations. In last class we have discussed that the anthropometric measuring techniques, and before that anthropometric landmarks were discussed. This is specifically required when we do not have any ready reference data for design application. We may need to generate some data, and how to generate that data last class we have discussed, and now today we will be discussing how the statistical treatment can be done on those collected data. Now, in last class we have mentioned that the basic anthropometric techniques in using anthropometric rod set and other equipments like height adjustable tools, weight, body weight and cone for grip diameter and etc., and measuring circumferences with the help of a inextensible or non-elastic measuring tape, and then using different grids, that is that anthropometric measuring boards are used, that can be developed, that can be done. Now, we have discussed the brief measurement procedures using anthropometric rod set, anthropometric board and specific measuring devices as suitable to measure some dimensions like grip, foot, etc. also. Now, that was basically we discussed for standing measurements, sitting, that is seat desk posture measurement, and sitting on floor posture, that is cross legged, squatting, considering static values as well as various dynamic reach values we have discussed in last classes. So, now today, and also we have discussed the indirect methods using photography and videography techniques and data collection accuracy system, how to make the data accurate in various static as well as dynamic postures, including various reach values we have discussed, and then recent development in this field using whole body scanner that gives digital dimensions, that provides us a scope for first covering many subjects, that is for anthropometric general survey it would be very good. And also we have discussed the easy sampling selection procedure, that is that if we do not have a very large number of population and we need to rely on some small samples, then it would be better to take around 20% I estimated smaller size people, 20% I estimated larger size of people, and then rest 60% randomly selected, so that we can make both the ends of that population from smaller dimensions to largest dimension we can consider, we can cover it. So, with all this, the today's topic is the statistical analysis of anthropometric data and the percentile value. Means that when we design something for a single person's use, then we can measure him directly, and according to those measurements we can make a design for his use, that is exclusively for his use, say a chair, a table or a bed, like that. But when means we can say that designing for a single person demands his dimensional variations to be well accommodated in a design. But when designing for a mass use and for unknown individuals use, which we do not know who will be the intended user, one of the most relevant statistical interpretations and considerations in this would be the percentile value of the collected data. Means when we are making a chair, then the popliteal height means the opposite side of the knee, the inner thigh, at an inner portion of knee joint, the popliteal height. So, we can say that the chair height should be at per popliteal height, but this popliteal height from whom we get a short height people, a large height people or an average height people, so that most of the people falling within this means small size to largest size, everybody can get comfort. So, in this situation we need a specific value, that is the percentile value of the body dimensions. Now, what is that percentile value and how to calculate and etcetera, that we will discuss now. Now, what is percentiles? The percentiles are the statistical values of a distribution of variables transferred into a 100 scales. The population is divided into 100 percentage categories ranked from least to highest with respect to some specific types of body measurements. Now, the first percentile of any height indicates that 99% of the population would have the heights greater dimension than that. Means if we measure some people, say 1000 people, we measure their heights. Now, the minimum height or the lowest height what we observed, if we consider it as a 1 in a 100 scale 1, and the highest value is 100 in that scale, and rest all the data are arranged within this 1 to 100 scale, then we can say that the what would be the 1% if we consider, okay, make a door with 1 percentile height of this population, means what's happened, the only 1% of this population, those height is within that limit, will be able to pass through without any problem. Now, if we consider the 50th percentile means the total population will be divided into two halves, means 50 percentile means below this 50 percentile around 50% of the body height, those who have lower height than that, they will feel no problem, they can pass through that door, but those who have higher value than that, they will have some problem, they may need to bend their heads to cross that door. If we see that 99th percentile data of that height means what's happened, 99% of the population will have a lower height than that, only 1% means 99 above till 100, only 1% population will be on the higher side, means over that data. Now, one question comes, normally for design use, in many everywhere it is said that consider the data from 5th percentile to 95th percentile. Why not 1 percentile? Why not 100th percentile always? It is said that from 1% below the 5th percentile value, these are almost freak data, and above that height, above the 95th percentile height, which means the tallest kind of thing, that is also freak data. So, suppose we want to make a bed for hostel purpose, hostel cot. For that, if we measure all the students, then few students may have very short height and few students may have very tall height. Now, if we say that we should make a cot where all the students can sleep without any problem, then ideally we can say that take the 100th percentile value, the tallest person's height of that population we measured, and make a cot, so that everybody falling below this height, they will not have any problem. Now, what has happened is from 95 to 100, these very few people will be there. So, if we make all the cots with 100 percentile height data, then there will be wastage of material resource. So, for that, this 95 percentile is normally considered as the higher value, and rest, if it is required to ensure safety kind of thing, then the maximum thing is necessary, and then allowance may be given. Like, if we do not want someone should touch a top overhead hanging some object, no one should touch at that very time, we should consider the upper maximum arm reaches maximum length, that is the 100 percentile length kind of thing. So, that below that height, everybody, all the people, they will not get touch into that dangerously hanging thing. In that, and then someone may raise their toe and can extend their arm reach and can reach it. In that cases, some extra allowance is to be added in this dimension. So, these are the some of the considerations that we need to be. Another thing, suppose in certain cases, everybody should get touch to operate some handle or switch like that, any control or for any control operation. In that case, it is that everybody should get touch to that. in that case we will try to consider the lower value of this arm dimension, so that higher valued people, they will not have any problem. So, in these cases we should use the lower percentile value. Normally it may be 5th percentile. Why? Now, below the 5th percentile very less population will be there, representation will be there, and they may touch it with extension of hand, means considering the peak data. So, these are the some common application for percentile value. Now, how to calculate this percentile value from a raw data, that we are going to discuss. Now, let us see in this slide whatever we discussed. Let us see the slide, see what specifically is mentioned here for reference. The first percentile of any height indicates that 99% of the population would have the heights of greater dimensions than that. Similarly, a 95th percentile height would indicate that only 5% of the study population would have greater heights, and that 95th percent of the body population would have the same or lesser heights. The 50th percentile value represents closely the average, which divides the whole study population into two similar halves, with one half higher and another half with lower values in relation to the average value. That is the 50th percentile value. Now, see this schematic presentation of percentile distribution with the help of stature value of a selected population. Now, suppose if we measure, if we see this is a diagram from some data, and 50 body height data we have taken here for discussion purpose. These are the data, original data collected in millimeter. Now, here the minimum value is that 1396 millimeter total body height, and maximum value we got suppose 1940 millimeter. So, 50% we have measured, and these are their data. Now, suppose the 1 percentile, suppose if it is that 1288 millimeter like this, which is a minimum height, then 50th percentile is closely average, or if our sample is proper, then average and 50th percentile may match together. Otherwise, it is not the same if our sample size is not proper. So, average suppose 1619 millimeter, and the maximum, the 100th percentile is 1950 millimeter. Now, if we transfer this in this diagram, in this graph, that is, suppose this is the value in millimeter. So, means, and this is the subjects. So, 1% data is here, 50th percentile here, and 100% like this way. So, the total graph is coming like this way. If it is possible, this total bell shape curve is possible if our sample size is proper. Now, the calculations. The calculation process is described here is an example taking the stature value, body height of a group of 50 individuals. This might help designers in the compilation of special data collected by them for special purposes, where ready sources are not available. It will also help them understand the method. Below is a reference data set to get acquainted with the calculation process. The stage 1, first stage is that to identification of the two end values, that is that the lowest score is this one and the highest score is this one. First stage 1. Stage 2 is that arrangement of classes, means from this lowest value and highest value, if we arrange, then total 50 value. So, now from the highest value to lowest value, if we minus it, from the highest value to lowest value, it comes 544 millimeter may be divided into manageable blocks. Say if 50 individuals are in this group, then we can say that so from highest to lowest, this value is in between, divided by 50. So, 10.88 classes we can have, means we can say that 11 of each class interval having 50 scores. For ease of calculation, a round figure of 350 instead of 1396, instead that to make it a round figure, we are considering 13350 instead of 1396, means 1350 we have taken it as a lower class. So, starting from 1350 with class intervals of 50, classes should be arranged till the uppermost class attained the highest score obtained in the original data. Here we get 12 classes as the following class distribution, like this. So, minimum we are taking 1350 and so 50 data, the next another 50, another 50, another 50, like this way we are crossing like this. So, like this way the topmost grade class 1900, 1949, in this the highest value whatever we originally got 1940 lies in this, and the lowest value, that is 1396 lies here. So, this is called calculation of groups with each class interval of 50 scores. We have considered arbitrarily this 50 scores. Now, the stage number 3, refinement of the class intervals. What is the refinement of class interval? That is that refinement of the class intervals and frequency distribution of scores are according to the classes and calculations of calculative or cumulative frequency, that is CUMFA for each class. The cumulative frequency for the lowest score containing class will be the same original frequency, and the rest will be by adding gradually the lower class intervals cumulative frequency will be the total number of the sample size. Cumulative percentage frequency is the next step to calculate corresponding to the cumulative frequency, considering the highest cumulative frequency value as 100. Now, we see the graph. So, here this is the class interval number 1, class interval 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So, total 12 class intervals. So, within this class interval, how many scores we have? How many tally? So, here if we go back to the original class, from here we can say that there will be 2, from this we can find out that 2 scores are falling within this. So, like this we have to consider that here 2 frequencies tally are there. So, counting this, how many scores are falling within this 2, here 4, in this 3, like that we found it the tally number, means the original scores falling within these classes. Now, means the frequency in these groups are 2, 2, 4, 3, 6, 12, 7, 7, 1, 3, 2, 1, 2, like that. Now, the cumulative frequency is that suppose in this group, in this class only 2 are there, in this class 2, but if we consider that 1449 this value, below this value total 4 are there, means 2 from the below and 2 of this class. So, total 4. So, this 4 will be below this. So, this is called, by adding one after another, it is the cumulative frequency. Like that the total 50 here will be below this. Now, this is the cumulative frequency by adding one after another. Means then this is we have considered 50 persons, means 50 individuals. Now, the 50 data we got it. Now, for percentile we are transferring this to a 100 scale. 100 scale means what happen? Then if we the top, it should be 100, means in this case it is just 2 multiplication. So, this cumulative percentage frequency would be 50 will be 100, 40 into 2 is a 96, like that 47 into 2 94, like that maybe 11 into 2 22, like that 2 into 2 equal to 4, something like that. This is the cumulative frequency. From this cumulative frequency and this our main calculation starts. Now, if we look at the bar diagram next, this is the examples. Now, if we see the bar diagram here, then what it says? Now, our class intervals were 1350 to 1399, next class interval was 1400 to 1449, like that. Now, if we see this one, then we can say that in now we are making these classes in a graph. Now, in this is the graph where the lowest value is 1350 and highest is at 1390. So, next group starts from 1400 and higher value of this class is 1449. But if we make a graph, then there this portion remains blank, means data from here 1350 to 1449, this portion remains vacant. For that purpose, like this way it is distributed. For that a specific case has been considered, that consider from what is the gap here. In this case from 1399 to 14001 is there. So, divide in by 2, because it is being, so this dimension, one value is distributed between these 2. So, if we divide by 2, that means 0.5. So, this specific group, if we start 0.5 below, means the score class, it starts with the true limit of this group is, the true limit will be 1349.5 instead of 1350, and upper value of this group would be 1399.5, means adding 0.5. The next one just below minus 0.5, it will be 1399.5 instead of 1400, means this point is being shared by both the groups. So, what is happened, all the groups like this, then there will be a fixed thing. So, no gaps will be there. So, the true value of the classes is 1349.5 to 1399.5, then next 1449 like that, and the scores are there as per within this 2 scores, within this 4 scores, within this 6 scores like this. After this, the main calculation part comes. The calculation is that we have to little see here. So, these were the original group class we mentioned. Now, if we for this, if we read this slide, what it says? If we look at the bar diagram that we have seen right now of the distribution, then if any individual score is between 1399 and 1400, it is not counted either in class first or the in second. To accommodate this, in the proper group, the mid value, that 1 to 1 point between the upper value of the lower class and lower value of the next higher class may be considered as the true limit of these two class intervals. That just now we have seen through this graph. Hence, the true lowest value of the class second class 1400 to 1449 would be 1349.5 like this. The same value also would be true highest value of this class if there is no possibility of its happening in manner, or if that minute consideration is not required. This step may be avoided in percentile calculation also. To sort out the true lower value and higher value of any class, this would be 0.5 less than the original lower value and 0.5 more than the original higher value is the true value. By this, it could be said that an individual score of 1399.4 would be counted in the true class of 1349.5 and 1399.7 would be in the class of this. Now, the calculation. First, I will discuss this table and then we will go for the its description. Now, the thing is that this is the original class minus 0.25 plus 0.5, this is a true value like this, this is a true value, this is a true higher value, this is the original frequency as we have seen earlier to in this class 2, 2, 4 like this way. Cumulative frequency the same thing, whatever we got with adding this 2 plus 2 equal 2 plus 0 is this like equal to 4, 2 plus 2 equal to 4 like this way, and 4 plus 4 equal to 8 like by this way adding we are coming to 50. Now, with this 50 this is the cumulative frequency is there. Now, we would like to see, suppose we want to measure or to calculate 25th percentile value. What will be the 25th percentile value of this 50% data? We can say that 20th percentile. So, with this cumulative frequency, the 25 is falling within this, means below this true limit there are 22% people, above this there will be other people, and 25th are within this true value somewhere. How to find it? Like this till 22, this is the upper value. Then from this value to this value, what are 50 scores are there? Originally 6 persons are here, frequency 6. So, 50 by 6. Now, if we see the calculation part here, percentile 25, the 25th percentile value corresponding cumulative percentage frequency falls in the class of 1550 to 1599. In this case, the true class of 1549.5 to 1599.5, and correspondingly to the cumulative percentage frequency, 25% position of the cumulative frequency will be the 25% of the total number n, that is 12.5th cumulative frequency rank. Means we want 25. In this case, what has happened? We have taken the double means into 2 like this, we got it from cumulative frequency to cumulative percentage frequency. So, 25 if we require, then 25 divided by 2 equal to 12.5. So, in this original cumulative frequency, it would be 12.5 score. So, till 11 is this is there. So, from 11 to 12.5, how far we should go? That is that below 1549.5 score limit, there are 11%, say 22% of the population. To get 25th percentile figure of this score, we have to go to the score that corresponds to the 12.5 cumulative, corresponds to the 12.5 cumulative frequency levels. That means 12.5 minus 11, 1.5 frequency score to the class. Means here is 11. So, we have to go to 12.5, means 1.5 we have to cross here. So, within this 50 there are total 6. So, 50 by 6 for one score, for one frequency, how much it crosses, then into 1.5 where it matches here, that will be the 25th percentile value. Means the class this has a frequency of 6, each frequency carries 50 score were there in one class divided by 6 equal to 8.33 score value for each frequency. Hence, adding 12.50 means if this is for 1, then 1.5 multiplied to this, then it becomes 12.50. So, with the lowest value here, with the lowest value, this one, if below this 11 were there, then this one plus 12.50 whatever is coming from here, if we add it, means 1.45.5 plus 12.5 equal to 1562 millimeter, which would be the 25th percentile score of this population group, where 75% of this survey of the population mentioned above for the first slide will be larger stature than this value, and the rest will be the below this value. So, like this all the percentile figures we can calculate accordingly. Like it. Now, this is by a calculation we have done, arithmetic calculation. Now, by a graph. In this graph we can say that suppose we are measuring a graph. This is the true cumulative, the true class values. In this class values, this is the cumulative percentage frequency. The frequency we are adding like this way. So, if we want to see that where the 8, this is 4, this is 8, this is 16 like that way as per the. Now, if we want to have a 25th mark in this graph is 25th, then where it falls this. So, count the measurement here and then because this each room is a, suppose from this interval to this interval is a total 50 data, 50 is there. So, 1, 2, 3, 4, 5. So, means each dimension is a 10, 10. So, then what would be the corresponding figure matches here, that would be the percentile. So, if we require 50 percentile like this way, if we require 75 percentile, it is like this way. So, it is a graphical system to measure that. So, percentile calculations by cumulative percentage frequency curve. Another thing that now, if we see whatever in the mathematical calculations we have, arithmetic calculation we have discussed, the formula would be that preferred percentile rank PP equal to L plus Pn minus F divided by Fp into I. PP means required percentile rank. If we require 5th percentile, then PP would be 5, P5. Then lowest value of the class interval, if we go till this, in the this is the 5 means it is here. So, this is the lowest percentile value, lowest interval of the class, lowest interval of the class plus 2.5 means this is that cumulative frequency in relation to the PP point, means we want 5. So, in that table we have calculated 2 multiplications from the cumulative frequency to the percentage frequency. So, 5 divided by 2, 2.5. So, below that class only 2 are there. So, 0.5 level we have to go, and divided by Fp means F is that cumulative frequency below the lowest value of PP class, and Fp is that actual frequency of the PP class. In our discussion case it is 50. sorry, actual frequency class is that it is number 2 in this case. In this actually the 2. Now, then into I means class interval score. In our case, we have taken the class interval of 50 scores. So, like this way. So, 14212 would be a percentile 5 value in this distribution. So, accordingly P percentile 10, 25, 50 etcetera will be one can calculate it. Now, the shorter the class interval, the more accurate will be the results. Now, mean, median and percentiles. The mean is the best, that is average, is the best measure of the central tendency of the distribution in the above scores. So, 50 scores individuals we have measured, value comes to 1637.5, but as per our percentile 50th percentile concern, it comes 1632.8 means 1633 millimeter, but here we can see that average is different. This may be due to non appropriate sample size. So, wherever this possibility is there, it would be better to take a mean percentile value, 50th percentile value for this. The median is the midpoint of a score arrangement from the lowest to the highest order, which would be the 50th percentile figure. In the above case, whatever data concern we are discussing, it is 1632.80 and its graphical presentation is shown figure below will show you. Roughly, for the purpose of a survey of anthropometric data, the subject number is vast and hence the references when addressing the 50th percentile value, the term average is also used, because normally for anthropometric survey a vast population size is considered. Now, in this case the graphical representation, if we see, now earlier whatsoever we have seen this graph, this bar diagram we have seen. Now, the center points if we do like this, then we will get the curvature. We will get the curvature like this way. So, in the graphical presentation of this distribution pattern of scores of a sample survey, the reference data used herein, A is the class midpoint. These are the class midpoints. This is the class midpoint, means minus it divided by 2, that comes the midpoint. Bar diagram with class true limits and original frequency is the B, this structure. These blocks are the bar diagram with true class intervals. C curve, this is the C curve, this one. C curve using class midpoints and original frequency, and this is the D curve, is this is the D curve, a smooth curve using class midpoints and smoothening the frequency. How to make the smoothening of the curve? True class intervals, then see that in this class interval what was the group ranks and then original frequency, and then by adding this. So, this system the calculation for smooth frequency of a corresponding group is that 2 times the original frequency of the original group plus frequency of the group just above the original group plus divided by the frequency of the group just below the original group, this is and divided by 4, this will be the smoothing points. By this, from with using this details, this smoothing of the curve is made and shown here. Now, the standard deviation and sketch. These are the standard deviation of a diagram that in any statistical book or reference book, this will be, these are given there. So, this is the bell shaped curve, that Gaussian curve, the ideal sample distribution showing mean values and standard and plus minus SD relationships. So, like this. So, from this mean value, if we have 1 SD minus and 1 SD plus, then it calculates 34 plus 34, 68% of the population will lie within this range, and then rest like accordingly this chart it can be seen. Now, in certain cases, if we see that the curves are in different structures. So, this cuteness, it shows that if our subjects sampling is not proper, then this type of curves are possible. Now, if most of the sources concerned near the mean value, then it is termed as a leptokurtic curve. If the curve follows a short height and spread towards both the ends, it is termed as a bradycardic curve. The normal bilaterally symmetric curve termed as a Gaussian curve and would always be mesocardic. Anthropometric data are normally presented in percentile figures with a range of minimum and maximum values, and sometimes with mean plus minus SD to understand the data distribution pattern in a particular study population group. It helps in selecting the required data of design relevance. Now, with this we can say that today we are completing the module number 3, that is human physical dimension concern, and the next new module will start, that is module number 4, that posture and movement concern. So, with this we are concluding today's session. So, next session will go for posture and movement and its design relevances. Thank you very much.